Hello engineers, welcome to the new video of the course, and in this particular video we are just going to understand what exactly is an Ohm's law. We are just going to understand its definition, that's it. Okay, so as you can see over here I had mentioned the definition of Ohm's law. So it states that the voltage across a conductor, okay, voltage across a conductor is directly proportional, okay, so the voltage, it is directly proportional to the current flowing through it, provided all the physical, this is very important, provided all the physical conditions and the temperature remains constant. Okay, so let's say if my temperature and other sort of physical conditions, all of them, they are constant. So what this particular law states, it states that the voltage across conductor, so if this is my conductor, if this is a piece of conductor, it can be anything, it can be an iron, it can be any sort of conductor, right? So if I measure voltage across the conductor, so this particular voltage V, it will be what? It will be directly proportional. It will be directly proportional to whom? To the current flowing through it. So it will be directly proportional to the current flowing through it. So this is what it means. This is the basic idea of Ohm's law. Okay, this is the basic idea of Ohm's law. Okay, again I'll just repeat. So you see over here, it states that the voltage across the conductor, is directly proportional to the current flowing through it, so I'm just highlighting few of the key points. Okay, so like whenever you will refer the PDF, it will be pretty easier for you to just understand that what we studied, right? So let me just highlight this particular point. Alright, so this is what we can see, that is my voltage is directly proportional to the to the current flowing through the conductor. Okay, great. Now whenever I say that my some parameter is proportional to some other parameter, so what does that mean? That means I'll assume it as a straight line, right? Obviously if I say that my y, let's say y is proportional to x, or let's say if I somehow remove this proportionality sign, so let's say y is equals to maybe 2x or simply x, right? Let's say y is equals to x. Let's assume the constant value is 1. So what, like how the graph of this particular thing it looks like, this particular equation looks like. So when I say y is equals to x, so if this is my y, this is my x, so it's pretty simple, this is how the graph looks like, right? I hope you are able to understand this. Okay, now over here let me erase this. I hope you are quite comfortable in this basic mathematics. Okay, so over here I have v, I have I, right? What I know is that my v is directly proportional to I. Let's assume for time being, if I remove this proportionality sign, and let's say whatever the constant value I will get, let's say this particular constant value, I don't know what this particular constant is right now, so let's assume that this constant is 1 for some time interval. Okay, so sorry, my bad, I'll just erase this. Yeah, so if you see my v is equivalent to I, okay, something like this, I'm just giving you a rough idea. So what I can say, if this is my v versus I graph, right, v versus I graph, so this is how it will look like. So as my voltage is increasing, so my current is also increasing. I hope you are able to understand this. This is basic mathematics, right? It's not like a rocket science thing. Okay, I hope you are able to understand this. Okay, so this is how the graph will look like if I plot voltage versus current. So this is how it will look like. So as my voltage is increasing, so do my current also increases. Okay, I hope you are able to understand this. This is basic thing. Okay, so this is what we deduce with the help of Ohm's law. Okay, great. Now what if I tell to you, I'm going to prove this particular thing, that how exactly this particular voltage is proportional to the current. Okay, we are basically going to prove this particular condition with the help of certain experiment, but that particular experiment we'll be doing in some other session. Okay, as of now we are just going to understand the concept of ammeter and voltmeter. What are these two things? So ammeter is a device, or it is an instrument used to measure the current through it. It is always connected in series with the load. Okay, so this is how the analog ammeter looks like. Okay, so whenever a current is detected, right, so this is how this ammeter looks like. So whenever a current is detected, so you see this particular knob, it will move something like this. Okay, I hope you are able to understand this. Similarly, you see what is voltmeter? It is an instrument used to measure the voltage across the load. It is always connected in parallel to the load. Okay, and same, this is the analog voltmeter. Okay, and you see whenever the voltage is detected, so you see this particular, now it will rotate in this particular direction, right? Either it will increase or it will decrease, right, depending upon the voltage that it will receive. Same thing will happen with the ammeter. So basically ammeter is used to detect the current, and just remember it is connected in series with the load. Okay, we are going to see that as well, don't worry about that. And voltmeter is an instrument which is used to detect the voltage across the load, and it is always connected in parallel to the load. Okay, so I hope you understood, or you got a basic idea, right, what exactly is ammeter doing and what exactly is voltmeter doing, right? Great. So now let's proceed further. And yeah, so if I connect certain battery to the circuit, let's say this is the circuit, this is the load resistor, it's a fan, right? Okay, so there will be some amount of current that will be flowing through this particular circuit because the circuit is completed, right? We have applied certain voltage, we have this particular load resistor, right? So obviously some current is going to flow. Okay, now you see over here how I have connected this ammeter. So you see this ammeter, it is in series with the load. Okay, this ammeter, it is in series with the load. So basically whenever you want to measure the current, I don't know what is the value of this particular current, what is the magnitude of the current, right? So to detect that particular magnitude, I'm just connecting one ammeter, and you see this ammeter, it is in series with the load. Okay, this is my load resistor. Okay, and this is the voltage. I mean, this particular battery, it is responsible to provide certain voltage. Okay, so you see this is how the circuit will look like. This is the voltage. Okay, this is the ammeter, and this is that particular load resistor RL. Okay, in this case it was fan. So you see it is connected in series, so both are in series with each other. Okay, I hope you are able to understand this. Okay, I hope you are able to understand this. Now let's proceed further. And yeah, so whenever you want to measure the voltage across certain load, so you just see how exactly I have connected this particular voltmeter. So you see this is my load resistor RL, and you see the voltmeter how I have connected. So you see this is how I'm going to connect the voltmeter. Okay, you see in previous case, like when we used to detect the current, we were just connecting the ammeter in series with the load. Now we are measuring the voltage, right? So to measure the voltage, we just remember this point, we always connect voltmeter across the load. Okay, across the load. We will never ever connect voltmeter in series with the load. This is very wrong. Okay, just make sure that like whenever you want to detect a certain voltage of certain load, so you always connect voltmeter across the load. Okay, and as you can see the current which is I over here, it gets divided into I1 and I2. Okay, that's the different point. We'll discuss this particular part in the upcoming session when we will focus upon the series and parallel circuit. So I'll explain that part in detail. Don't worry about that. As of now, you see, just remember this point, whenever you want to measure any voltage across certain load, so you are going to connect it in parallel with that particular load. So you see they both are in parallel, right? Both are in parallel with each other. Okay, and this is how it will look. It seems I just forget to show V. So this is my voltmeter V. Okay, and this is how we are going to connect it to the circuit. Okay, you see this is my voltage over here as well. This is the voltage, this is the load resistor RL, and this is the voltmeter connected across the load. Across means what? In parallel with the load, right? Across or parallel, right? Hope you are able to understand this. Okay, as mentioned, it is an instrument used to measure a voltage across a load. It is always connected in parallel to the load. Okay, this is very important. I'll just highlight this point: parallel to the load, connected parallel to the load, and it is connected in series with the load. Okay, so I hope you understood this particular few of the points that we discussed. We just understood, or we just gain a basic idea about Ohm's law, like what exactly it is trying to tell. It is trying to tell that the voltage which is appearing across the conductor, it will always be proportional with the current flowing through that particular conductor. Okay, and just with the help of basic equation, which I hope you might have studied in case of mathematics, that is y is equals to x. So we just deduce this particular kind of graph. Okay, not necessary that the constant we will get over here, that is v is equals to I times of whatever that constant is. As of now we really don't know what is that constant. We are going to find out this constant with the help of the experiment, right? So just assume as of now that it is 1, and based upon that we will get v is equals to I. So just plotted this particular graph, and this is how it will look like, a straight line passing through an origin, right? So we just did this, okay, this based upon certain assumption and all, okay. And then what I explained to you, I just explained you few instrument, that is ammeter and voltmeter. So ammeter, it is responsible to measure the current, and it is always connected in series with the load as shown over here, okay. And similarly the next instrument is voltmeter. It is an instrument used to measure a voltage across a load. It is always connected in parallel to the load, okay. Nowadays we hardly use this kind of analog instruments. In fact, we prefer to use multimeter, okay. And as I have already explained why, because multimeter can perform a lot of function. It can measure the current through some load. It can measure voltage across certain load. It can measure the gain of the BJTs, and it can perform various other tasks as well. So we are getting digitalized, right? So we mostly use digital devices right now. We hardly prefer to use this kind of analog devices or analog instrument, but still you will find this kind of instruments in some schools and colleges, okay. And yeah, so you see voltmeter, it is connected across the load, or they both are in parallel with each other, okay. So these are the few of the things which we discussed right now, okay. So what I'll do, I'll just end this particular session. And why I explain you this particular entire thing, because we are going to use these two instruments to do the experiment based on Ohm's law, okay. So that's the reason that why I explain you these two instruments right now, okay. So I really hope that you understood each and everything up till here. But still, if you have any doubts, if you face any difficulties anywhere, it's my request to you all guys that you please ask those particular doubts in the communication section. I'll be happy to help you out there. So thank you for listening patiently. I'm ending this video over here. Thank you.